system design can be, or how we use it in our day-to-day life while you're working as a software programmer.
Okay, so my opinion about system design would be the end-to-end high-level plan on how to design, develop, and maintain maybe an app or a product. Yeah, so apart from just maybe doing the planning, there should also be plan on how to scale it as it grows, how you're going to push updates, and as users increase, how it's going to be scaled.
That's
And maybe
correct.
how new features would be added to it.
That's right. Awesome. Anyone else? Okay, so I'll just give you a brief overview before we jump into this. So today, what we're going to do is we're going to design the Airbnb application, how the system design can look like for an Airbnb app, right? How we can make it scalable, more resilient, more having less runtime, high availability, low latency. So these are some technical terms that are used in system design. We'll get over each term once we start designing it. And also we're going to look into how we can, what are microservices and how we can convert a monolithic application to a microservices application. So let's start with the first thing. What is system design? So system design is the process of defining the architecture, components, modules, interfaces, and data for a system that satisfies the specific requirements. So in a general sense, you can say it's a blueprint of something. Let's say if you're building a house, right? To build a house, you need to first create a blueprint of how it looks like. So when you create that blueprint helps you to ensure that the system will be built correctly and meet the needs of the user, right? So if you directly start building the house, uh, you won't really know how to kind of create the map of the house, where to which room will be at which place, right? You need to first create that blueprint in order to make sure that everything is put together that makes sense before you could start creating the house. Same thing comes in designing a product. So whenever you're going to design a product, you need to make sure you do a proper planning first. You need to take the functional requirements, non-functional requirements from the stakeholders, and make sure you design a system in such a way that it meets all those requirements. So if you remember for Feed app, we did gather some functional and non-functional requirements, and even for the capstone. So at that time, we designed the database in such a way that it met our non-functional and functional requirements, right? So first thing that we're going to learn is what is microservices architecture. So how many of you guys are aware of microservices architecture? What do you think microservices can be?
Okay, so the microservices architecture is one that brings together, will I say, already built parts and couples them as a whole. Yes. So for example, a clear example would be maybe our weather app, where we didn't build where we got the weather information from.
That's right. Yeah. So you can say microservice architecture is an approach to a system design and development that involves building application as a collection of small independent services. So right now, how we build the application, how we learn to build the application is a different architecture in which we put all the modules, all the services together, we coupled it in one service. So right now, if you see your backend for Feed app or your weather app, it's all the services are coupled in one service. If you have a feed service that is adding a new feed, liking a new feed, commenting a new feed, getting others' feed, get your feeds, right? Those are coupled in one single service. So that has a many disadvantages, right? So we'll get over those disadvantages in the next slide. So for now, if we are going to design this feed app into microservices, what you'll do is you'll probably decouple all the features of your application just to make sure it's more scalable, more resilient. It has more uptime. Let's say if in your application, more of the traffic is on the get feeds API endpoint, right? Where you're getting the feeds of other users, and add feed and other endpoints are not having much traffic. So at that time, what would you probably do? You'll try to, sorry, you will try to spin up more instances or give some more hardware to your uh, get feed service so that more people can access it. But at that time, do you think you need to give more bandwidth to the other services if they're not being used that much? No, right?
No.
Why will the company spend that much infrastructure cost on a service that is not frequently used by the users? So in based on what we have right now in our application, what do you think in case your get feeds service needs more infrastructure so that it can handle the requests? What do you need to do?
Increase the amount of servers.
Yeah, you need to increase the amount of servers, right? But if you increase the amount of servers, those servers will also be increased for the other services, like user service that is not being used much. So what's the disadvantage there? What do you think?
Waste of resources.
A lot of waste of resources, right? If you only had get feeds, if you had to spin up like five more instances to make sure that it is able to handle the traffic, you have to spin probably 20 instances just because all the services are coupled together, right? And user service will have equal number of instances as your feed service have. So that's where you will spend more cost on that. So let's look into the disadvantages and advantages of or let's try to compare the two type of architectures. So right now our feed app is designed in monolithic architecture. So what do you mean by monolithic architecture is when all the services are coupled together, right? Right now a user service and feed service. Those two services are coupled together. So that's your monolithic architecture. And in microservices architecture, we divide these services in small components or independent services that will communicate to each other. So in microservices, if you need to increase the
That's what I hear,
okay, who's this? Can you mute, please?
guys, but I'm gonna go check this out.
Wait for me.
Okay. So now in microservice architecture, whenever you are going to create the same application, right? What you'll do is probably you'll only spin up more instances for feed service. You don't have to do it for user service. So based on the monitoring rules, they will automatically spin more instances for your feed service. Your user service will still have the same amount of instances, which are still able to handle the amount of traffic that you're getting. Make sense? So second thing in microservices monolithic is right now we built some app APIs in Java, right? Let's say after 10, 15 years or some time, Java won't exist or there are new, more modern technologies that come into existence. What do you think will happen at that time if you're using monolithic architecture?
And you have to essentially rewrite it if you're
You
going to
have
use
to,
that new code.
that's right. You have to rewrite the whole application to make sure that it's built in the modern frameworks. But let's say if you're using microservices architecture, so in that case, each service can be written in a different programming language. If you have user service in feed app, for example, I'll keep taking example of feed app because that's where you're familiar of, right? You know each part of it, so you understand it better. So in feed app, we have two services right now, user service and feed service. So let's say you develop these two services in Java later on going forward, there is a new modern programming language that comes up and you can easily switch or create a new service in that language. Keep all the services in Java, those are already developed, and any new service that you will develop to scale the application, you can probably do it with other languages. Another part, if you see it in terms of or from the view of a business perspective, why most of the business have started choosing microservices is going forward, if it's hard to find a Java developer, right? Because there are more new languages coming in, then they can easily hire developers for the language or the framework that is going these on those days, right? And they can start writing services in the new modern framework, and they can simply connect it with the other services. So these services can be easily connected to each other. We'll get to know how we can do it. Then it's easier. So monolithic architecture, it's easier to develop and test because everything is coupled together. You don't have to really take care of how the services will communicate with each other. So it's easier to develop and test. And then for microservices, you require more advanced design and management techniques to test these services, because every service will be written in its own language. They'll have its own pros and cons. They'll have their own ways how they work, right? So you need more advanced design and management techniques there. So talking about one, I think changes to one part of the application require redeployment of the entire application. Let's say there was a very minor change in the user service that you need to change the pattern of the password. You need to make it more strong how people create the password. Now, in between, or there's a very hot fix that needs to go right away because there's an error that is not letting users to sign up. So in that case, if you need to redeploy the application on server, you have to kind of restart the whole server, I would say, right? You'll restart the feed service as well. So at that time, there will be a downtime of your service, your feed service. So if the issue is in user service, why would you probably why should it affect the feed service, right? It should not. So if you talk about microservices, as the services are decoupled, so change to any one service can be deployed independently. You don't have to kind of restart the other services. So if your user service needs a hotfix, you simply restart your user service, update the new code, your feed service will remain as it is. Make sense?
Yes.
Okay, any questions before I proceed with monolithic and microservices? Yeah, okay. So now let's try to design our feed app using microservice architecture. Let's see how it will look like if you had the same app using microservices. So right now, what we have is we simply have a feed app backend, right? So what does feed app backend consist of? One is your user service, right? That helps you sign up a user, log in, forgot password, reset password. What else you have?
Feed service.
Feed service that will help you to add a new feed, delete a new feed, uh, do a like, comment, or get the feeds of others and yours. What else you have?
Email service.
Correct, that email service. So what email service is doing is it's sending an email for reset password, then for your new registration, right? So this covers our feed app. It's a very high level view, right? So what type of architecture it is?
Is it 3-tier?
Sorry,
3-tier architecture.
monolithic.
Oh, okay.
Yeah, I was say monolithic. Like one service can operate without the other.
Yeah. Okay, so here now you see if your feed service is getting more number of requests, you need to probably this is the one container, this is your server, right? You need to probably spin up more servers. So let's say if you spin up more servers, you'll create copies of these, right? So if you have 4 servers running together, you'll have 4 copies. Why do you need these? If your feed service is getting more requests, you're probably wasting resources here, 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 and here, right? So we don't need these resources. It's kind of so when you for an IT company, resources are the asset, right? So you have to make sure you use less number of resources because resources are expensive. When you spin up a server that handles millions of users, that's pretty expensive. So you have to make sure whenever even you code or write a function or anything, you have to write it with the least complexity, right? So same thing applies when you see application from a higher level, that's your system design. You have to make sure you create the application that have the least complexity, have more uptime, right? So we don't need these services. We only need these three services to be spun up. But that's not possible with monolithic architecture. So that's why microservices architecture came into existence. So now let's see how we can convert this to a microservices architecture. Okay, so let's say these are the users who are accessing the services, right? And now we're going to divide the three services into different user service, feed service, and third one was email service.
Email service.
So now these will be hosted on different servers. Here we only had one server instance. So in the morning, in the Carlo session, you see how you hosted the application, right? There was only one server that was hosting the whole application. So now each service will have its own servers, right? So let's say a new user comes in, he wants to get the new feed. So here we'll add a load balancer. So for now, let's relate load balancer as a route. So you design the routing, right, in React application. For now, let's relate it as a route. We'll get to know what exactly load balancer is. So whenever a new user comes in, let's say this is user one, he needs to add a feed. Or sorry, register, or you can say login. So user one is going to login. So user one will go to load balancer, and the route for login will be, let's say, /user/login, right? It will go to load balancer. Load balancer will read this route, what the route is, right? And based on the route, it will redirect the user to the specific service. So from here, where it should go?
User service.
It will go to
Right? It will go to user service, and then user service will have a database. So this is your users data. It will only store users data. Each service will have their own databases. They won't communicate with others. So if feed service wants to communicate with user data, it can't directly communicate with like this. You can't create a connection. You need to request users data from user service, right? So there are techniques on how we can do it. Then your request is passed to user data, right? And then you do the login and the response is returned. So next, let's say if your database is down due to some reasons, there are some errors or it's overloaded, what you can do at that point? Or what do you think we can do?
Yeah, we can quickly spin up another server, a replicated server.
So
Sorry, what was the question again?
So in case the database is down, what will happen to user service?
Oh, user service will be, it won't be.
It won't be accessible, right? So what we can do to prevent that?
Yeah, replicate this.
Yeah, that's right. Awesome. Yeah, so we're gonna do data replication. This will be copy one, right? And there will be copy two. Let's say for now, let's create two copies. So there will be two copies that are managing this will be your master, this will be your slaves. So your user service will always get data from master. In case master is down, then the master instance will start getting the data from your copies. So if this instance is down, you still have 2 copies of it. This is called data replication. Whenever you add a new user in your master database, it will automatically be added in these 2 databases. These 3 databases will always be in sync, right? So whenever this database is down, this will become your master and this will become your slave. So whenever there's new data in master, it will automatically sync here. And whenever this master that was previously master comes back live, this master will, your copy one will sync the same data on the master, right? Because it was not live for, let's say, 10 or 15 minutes, it didn't have the data that was pushed in during that duration. So this copy will automatically sync it here. So these 3 databases will always be in sync. Make sense? Okay.
Yeah, I wanted to ask real quick, because we are signing in and we're using tokens. So how do we manage the tokens on multiple servers? So how do
It
we
will be done on the load. So there will be another service called auth service. So auth service. Okay, if you want to go that way, let me inject it here. Okay, so there will be another service called auth service. Whenever you're going to do a login, right, this will communicate with the auth service. So auth service will have another database called user data, right? But it will only have user credentials. It won't have the whole data, user credential. That's it. That's your email ID, username, and password. So now, even if feed service, you're going to access the data in feed service, when you will call feed service, it will first communicate with your auth service to ask whether the user is authenticated or not. Make sense?
Okay, thanks.
Yeah, I don't want to go that side. There is a few concepts that only these 3 services can teach you better. So now, what happens whenever user will register? So let's say there's a new user who is going to register now. If a new user is going to register, here in the register, you need to send an email, right? So if your user service, let's say there are 100 to 200 registrations every 5 minutes. So how many emails you are sending? Almost 200 emails every 5 minutes. So if email task is a synchronous task, right? When you send the email, you wait till you get a response from the third party provider that email have been sent. So that what was the disadvantages of what do you think how it is affecting our service?
I think it's gonna be moving quite slowly.
Yeah, that's right. So if your login button, you're adding a new user, and also you're sending the email. So let's say email is taking 3 to 4 seconds to get a response from a third party provider. Right now we use Gmail, right? That the email has been sent or the request has been processed. So you're kind of wasting your resources there, right? You're waiting there for no reason. Even if the response is failed or even is passed, you're still registering the user, right? So probably what you can do is in user service and register, you can just register user simply in the database and send a request to your email service that send an email to that user. So email service will take care of sending an email to the user. Your user service will directly return the response to the user. So you might have noticed whenever you register, sometimes it takes few seconds to receive an email. Not on Feed app, I mean on any application that you have used in past. Sometimes it takes a couple of minutes or few seconds to get an email. Why is that? Why do you think it happens?
Email filtering.
No. Try to relate it what we just saw, how user service is communicating with email service.
Probably because there's a queue of requests.
That's right. So when your email service, when you will send user service, as we're not going to, user service is not going to wait for email service to complete the processing. You will keep sending the requests to email service. Email service will have a queue in which the requests are being queued, right? So whenever there is more traffic on registration or email service will send emails one by one. Let's say if there are 200 requests stacked or sorry queued in your email service, they'll be sent one by one to the users. So when there is more traffic on the server or there are a lot of emails that the service has been sending through when you registered, at that time you might see some delay in getting the emails, right? So that's the major reason why your emails gets delayed. Make sense? Because if there are 100 users registering, they will not wait for email service to complete the request. They'll simply queue their request in email service and email service will process it one by one. Make sense? Okay, so now let's talk about the fee service. So now let's say another user comes up. He's going to add a feed or add a feed. What's the endpoint? Let's say user slash feeds, and the type of request will be post request. So now this user will go to load balancer and load balancer will check the route, and now load balancer will forward that to feed service. So what feed service will do is, again, it will do authentication with the auth service. It depends on what kind of authentication you use. Like Charlie just mentioned in the chat, you can use OAuth. With OAuth, you don't really have to communicate. You don't need a third service, that's auth service. Your OAuth algorithm will be able to tell you that whether the user was authenticated from even different service or not. So you pretty much don't need that part. So there are different type of authentications that you can implement. So now let's talk about feed service. In feed service, we'll be having another database called feeds data. That will again have some copies. So whenever you'll add database, something to add a new feed, then you will get replicated two things. So which part do you think will have more traffic out of user service and feed service?
Feed service.
And which exactly route will have more traffic?
Get
feeds, right?
feeds.
Or you can say get timeline. So instead of coupling add feeds and get feeds in one service, can we decouple it again? Because add feeds will not have much requests as get feeds can.
Yes.
So let's decouple it. So let's create another service that will call timeline generation service. So what this timeline generation service will do is this will give you the feeds for your timeline where you see the feeds on your home screen. So now another user comes in. So this will be group of users now. So group of users are trying to get feeds. So URL will be /feeds, for example, feed/others. So again, this will go to the load balancer. And then load balancer will redirect the request to timeline generation service. So timeline generation service will have a database of feeds data, right? And then it will have copies of it as well. So what type of copies do you think we need here? So these will be called as read replicas. So
Read
what do you
only.
mean by, there are two types of replicas that you can make, read replicas or write replicas? right? So write replicas are those in which you are going to write intensively. Whenever there is a request, your data won't be fetched from write replica. It will be fetched from read replica. So we'll have two read replicas and one write replica. So why do you think we need one write replica?
So that you can still write data, but it's just that it won't be writing as much as you're reading.
So user is adding a feed in feed service and it is stored in feeds data feeds data database on the feed service level. How do you think the data will come in there? See. You need the data here as well, right? Whatever user is adding, you need here.
So you basically use it to update whatever is seen on the read to ensure that both sides have the same info at all times.
How would you update it?
Whenever the feed service is called, you'll probably sync it with the.
So whenever a new feed service will be called, they will be adding a new feed. At that time, you will pass that feed to the timeline generation service to add the feed. Now, timeline generation service is very smart. It's a smarter service of all of this. So these are just doing the CRUD operations. This service will use caching, right? It will cache the recent feeds. So whenever you'll add a feed, timeline generation service will keep adding the same feed. You'll pass a request to a service. This service will keep adding the feeds in feed data and smartly removing the stale feeds. What do you mean by stale feeds? Those were like from a day or two back, right? You don't need all the feeds here. All the feeds are already being stored here. You only need here the feeds. Those will be fetched by the user. So there will be algorithms that you will design smartly how you can how you need to read users insights, how user is looking into or let's say if I'm looking into John's feeds all the time, right? And I will be, whenever I'll fetch from timeline generation service, for me the feeds which will be fetched from this data will be of John's. So I have to look into very smartly. This service will be the smartest of all. It will have a lot of algorithms, a lot of caching, right? That is being done. So let's say if a user fetch top 10 feeds from timeline generation service. After 5 minutes, he's going to refresh it. If there is a new feed service will stack that feed at the top of your timeline generation service. And instead of going to feed data after 5 minutes, timeline generation service will take those previous feeds that user already saw from cache and add the two new feeds to it and return the data to the user. So you'll implement caching here so that you're caching the recent GET request that user already did. So this covers it's a very high level view. There are a lot of things you like here. You're gonna use Redis cache, right? Load balancer will have a lot of things. Here we're going to combine them into K8s. We'll get into that when we're going to design the Airbnb system design. Okay, any questions with feed app? So here, ideally, we converted our monolithic feed app into microservices.
So just to reiterate, the caching kind of cuts down the load on the servers, right?
Yeah.
Okay.
So with caching, what happens is, I'll just give you a basic example. Let's say this is your database, right? This is your service, and this is you. So if you're going to search for, let's say, PS5 games, right? Let's say this is an Amazon search engine. If you're going to search for PS5 games, ideally what your service will do is it will go to your database, find the products which are related to PS5 and return you. That's the normal way of doing it. Next time, again, I come back, you come back, again, you do the search for, same thing for like after 5 minutes. It will again go to your database, right? Return your response. So instead, so right now, do you think you're wasting the resources on this level? What you can probably do is, this is your service, right? So when a user will, you as a user here, so you as a user will request for PS5 games. Your service will first check, it will have a cache engine right here, right? So your service will first check whether there was a search already made for PS5 games. If it was not already made, then it will go to database, right? Now next, so first time, let's assume the search was never made. So will it go here? It will go here, but from where it will fetch the data?
Database.
Database, right? Because first time you search for PS5 games, no one searched it. So it will fetch the data from database. Next time, another person, let's say John comes in, he again search for PS5 games. So your service will check whether it's there in your cache engine. If it's there in the cache engine, it will probably return that data from here. You don't have to go to database side. You already have the results stored in the cache, and you'll return this data. So if cache will take 1 millisecond to return the data, database will take 5 milliseconds. So you're still decreasing that traffic. You're still decreasing that load. This is just an example. This is just a rough numbers, right? So you see now how you are decreasing the traffic on the database level by caching, because caching is in the form of key value pairs. Those are hash maps, right? So the complexity to get the data from a key value pair, or you can say object, or you can say hash map, is way less than searching through your database. Database will be probably ON or N by 2, depends on how you index your database, right? It can never be O1 for sure. It will be at least N by 2 or O log N to search for that particular row. But if you are searching the same thing right here in your cache will be, who can answer? What's the complexity to search in key value pair?
O1.
O1. That's right. If you're searching for PS5 keyword, it will directly fetch the results. Yeah, and talking about James' comment, caching always expires. Whenever you, so let's say today, Sam, you search for PS5 game. After 10 minutes, John search for same thing, it will go in cache. But cache will expire after a few minutes or a few hours. It depends on our use case, how we set the cache. Let's say we set it after an hour, it will expire. What's the reason behind that? What do you think? Why we need the cache expiry?
To prevent cache bloating.
Okay. What else?
If the pieces aren't being queried in the cache, then there's no real reason to keep them in there because it's just taking up memory and space in the cache.
Yeah, that's one reason, but not. I won't say it's a primary reason. Was a primary reason? This is one of the a reason that we normally keep clearing out the memory in cache.
I would have to say for security reasons.
Okay.
I mean, yeah. So when the cache gets played, well, any man in the middle of that call, I mean, just in terms of security, that would be my first thoughts.
From that aspect, it depends whether you have implemented VPNs that is secured enough, right? But there is one major reason why we clear cache. What do you guys think?
Thinking like maybe like a data refresh or something, but I don't know if that's right.
Okay, that's right. So, for example, you search for PS5 games. For let's say example, let's say at that time FIFA 2023 was mostly purchased game, right? So if your Redis cache is storing the stock, right? It's showing you like 5 pieces left, 6 pieces, or something like that. It's stale data. 4 or 5 people already ordered it. It's already out of stock. You can't show that, right? So it's basically you can say uh, you are going to you have to consistently remove the stale data out of your cache. So because database will always have the fresh data or the recent data, but your cache may have data that is stale. So you have to be smart enough to know that what can get expired, which data can be expired more sooner than the later, right? So you keep removing that part from your cache. So if in this example, timeline generation service, what do you think can expire more sooner?
On the feeds that they get in.
Likes and comments, right? There can be more likes and comments. So probably you have to not either you don't store it in the cache. If you store it, you have to store it very smartly, or you keep fetching the fresh data from your database. Make sense? If we gave an option to edit a feed, then also your cache will maybe it can be a chance that your cache is storing a old feed. So if you need to update it, how would you do it? So whenever you will update a feed in feed service, right? In the timeline generation service, you have to update that cache as well, or that key value pair that is being stored in the cache. If you don't update it, it will store the previous value of your feed. Or you simply delete it from your cache whenever there is an update, and let the service fetch the fresh data from your database. Make sense? Okay. Charlie, how much time do we have for?
Let me check. I mean, technically, you still have 20 minutes if you have other stuff you want to go over, but
Okay.
maybe you could open it up to questions if you want.
Okay, I still have a couple of slides. Okay, I'll give you guys 2 minutes to review this. In case you guys have any questions, feel free to ask. Then we'll move into designing the Airbnb application. Okay, so now let's move into designing overview of Airbnb. You guys are already familiar what Airbnb is, right? It's a global marketplace where you can uh, rent out homes or spare spaces, or you can say rent out villas for a short time accommodation, right? So how Airbnb works basically, there are travelers, right, and hosts. So travelers kind of go on the application, first host puts up their accommodations or the properties or the application, right, which are available for rent, and then travelers go on Airbnb to book them for rent, right? That's how a basic overview of how Airbnb works. So in the morning, you guys, so we're going to design this using we're going to do a system design using AWS architecture. So in the morning, in Carlos' session, I guess you guys went over EC2 instances, right? So that's one. AWS is a whole universe into it. There's a lot of things in AWS. You think of something on the system design level, it's available on AWS, right? Same thing for who are the competitors? What do you think might be knowing of AWS?
Microsoft Azure.
Microsoft Azure, yep, that's one.
GCP.
Yeah, Google Cloud Platform. So right now, these are three main providers which are trending in the market: AWS, Google Cloud Platform, and Microsoft Azure. They are one or the other ways doing the similar task. It's just the different names of the products that they have given for each service, and might be some different functionality that you have to do to make those services work. But at the end of the day, they give the same output. So talking about the importance of well-designed system, what's the importance behind designing a system that is having less downtime? So first thing is your scalability. You have to make sure your system is scalable at any time. When you deploy your services at that time, if you have 100 to 200 requests each day, that's for sure you will get more number of requests in the coming few days, right? If your product is good. So you have to make sure your product is scalable. Second, your product should be reliable. So it should be robust system. Let's say if you place an order on your application, user did the payment, later on that order should not somehow get deleted or something like that, right? You should still see it. So other example is, let's say you did the payment for an order, that payment didn't go through, but you still dispatch the order. Probably the mistake is on our application side that the payment was not done. How we can still dispatch the order? So that can result into the loss of revenues. So you have to make sure you design very reliable system. Next is the performance. So your system should always have a good uptime and low latency. So that means it should be highly available to the users. Then is the maintainability. So in maintainability, you need to make sure that whatever resources you are using, right, it takes less time for you to deploy it, and it takes less time for you to maintain it, give the updates, right? So that's what basically comes in maintainability. Then you have security. That's the top priority every time. You have to make sure your data is secured, users' data is secured, because user data is very sensitive. You might be storing sometimes the credit cards of users on your database. So you have to make sure you encrypt them. You use strong algorithms to store those kind of data, right? You have to implement proper security measures just to make sure data is not breached. And next is your flexibility. So flexibility, we talked about how we're decoupling the services. Any new feature should not affect the other services, right? So you have to make sure your system design, or you can say the system you're going to design, is flexible. Cost effectiveness, again, this thing we just already discussed, how we can decrease the cost of the server, spinning up a new server just by kind of creating microservices. If each service is getting more users, we probably won't go for increasing the resources for user service. Make sense? Okay. So these are a few services from AWS which we are going to be using designing the system design for Airbnb. So I'll just go over the terms, and we'll go over what exactly each service is doing in the diagram. So first is your Elasticsearch. So Elasticsearch is kind of a search that as having very less response time. So again, it uses key value pairs, right? Hash tables. That's the reason why it has very less response time. Then Kubernetes is used to create containers, or you can say orchestra of containers for each service. So if you talk about this, whole thing will be coupled into one Kubernetes orchestra container. And these are small Docker containers, right? So what Kubernetes will do is, in case you can treat Kubernetes as a manager for these services. So in case feed service is getting more requests, Kubernetes is smart enough to automatically spin more instances for feed service. So there will be 5 feed services here. Let's say Kubernetes will make a copy of your master service. So whenever there is more traffic, this instance is not able to fulfill it. It will automatically redirect it to other instances of the same service. Make sense? Okay. Next is your load balancer. So load balancer will automatically distribute your incoming traffic to your specific service. Then you have SQSQ. So this is what John was talking about. If you are going to send, you register 100 users at the same time, right? We're going to send email survey request to email service. You won't wait for the response here. It's an asynchronous request. So what you will do is, there is a tool in you can say service in AWS called SQSQs. So you can simply queue your request in SQSQ, and your email service will take that request from that queue and process it, right? So there will be another object here. Let's say this is that queue sitting in between these two services. Yeah, Bukhara, you have any questions?
Yeah, I just wanted to get something clear. You said, let's say in an instance where there are more traffic on, let's say, feed service, and the Kubernetes app tries to create copies. When the traffic slows down on that other feed app, on the feed service, what happens? Those copies that are made, do they like revert back to normal, or they just remain?
So it depends how you set up your Kubernetes. It works 2 ways. First is you manually increase those, right? Second is you let Kubernetes manage it. If Kubernetes is managing it, whenever the request will decrease, Kubernetes will automatically remove those copies. So
Okay,
it totally depends how you configure your Kubernetes.
All right, thanks.
Yeah. So most of the people do it automatically. Let Kubernetes handle it, right? Because it's smart enough to know how many requests they're coming in, how he needs to spin up more instances or spin down. Make sense?
Yes, thanks.
Okay. So next is your Amazon Route 53. So what Amazon Route 53 does is, it is a domain name system that allows you to manage and route traffic to your application. So let's say in the morning, you guys hosted the feed app, right? I forgot the URL, what was it? But I'll just, for example, let's say the feed app is hosted at https://feedapp.com, right? So you need to map this to your server, this domain. This is a domain, right? So on Amazon AWS, Route 53 is used as it's a domain name system which will help you to map your server domain with your servers. Then you have RDS. RDS is the database. So RDS, you can spin up instances for your database using RDS service. It allows you to deploy your database in different form. Let's say if it's MySQL, you can choose what kind of database you need. So MySQL, Postgres, MongoDB, whichever are the most used databases. RDS is the managed, you can say, server instances for your database. You don't have to install operating system, install database. Those are already pre-installed on whichever RDS you spin up, right? Then you have auto scaling group. So this is what I was talking about. who asked the question, I forgot. Auto scaling group. This we inject auto scaling group to K8s. So whenever there is more traffic or less traffic, the auto scaling group will automatically kind of scale them down or up based on the traffic you have. You don't have to worry about let's say if in the midnight you get more users, you can't just manually do it at the midnight, right? So auto scaling can automatically spin and down your user end at any time. Make sense? Then we have Amazon CloudFront. So CloudFront is a type of CDN. So basically what CDN is, it helps you to keep the static data near you. So let's say there is a static website, or you are where you have some static images. Those are same for each user. There is no data on that page that is user specific, right? Everyone is able to see the same user. Let's say, for example, about page, contact page, they will be similar for everyone. So you can implement. So what happens is whenever you will open the contact page, let's say you open in Toronto, and another user is opening it in Brazil or China or anywhere else in the world, your servers are in states. So anyone from Toronto query that server for contact page will have less time than anyone doing from Brazil or China, right? Because they are far away from your state server. There's a long distance that they need to cover. So what happens in that case is we implement CDNs. So CDNs is a global content delivery network, and they have servers in each part of the world, right? So when you deploy your application, you inject CDN to it. What CDN will do is whenever someone from Brazil will access the contact page, CDN will cache that contact page on its own server, right? And next time when the same page is being queried, your request won't reach to the state server. CDN will automatically take that cache data from your the nearest server that it's being hosted and give you the response. So first time you're accessing that data, that contact page will take, let's say, 5 seconds for the response. Next time you do it, it will just take not even 1 second, right? It will decrease that response. So how do you think CDN is helping you? What are the various factors where it can really help you? You can think of how on the resources level, how it's helping you. Anyone?
I think you can cache stuff as well. So you don't end up interacting with the database a lot.
Yeah, it caches stuff. So what happens when it caches stuff?
It basically allows the users to interact with that data repeatedly without directing that traffic onto the database itself.
So can you say that it can decrease the server cost? Or
Yes.
querying the server again and again, that decreases the traffic on the server? Because if someone else from Brazil is going to, it helps two ways. It helps the users to get the data in faster, right? It also helps you to decrease the server cost. You don't really have to query your server all the time because the static content won't change that frequent. So you can easily get it from your CDNs. Make sense? And the last one is your CloudWatch. So CloudWatch is a monitoring tool that helps you to log any errors or any alarms. Let's say if you told Kubernetes max servers you can spin is 1,000, least you need to keep it a 5. So range, if more users, you can spin at max to 1,000. Let's say if your request goes beyond 1,000, your 1,000 instances are not able to handle the number of requests you're getting on a server. So you can implement those kind of things, alarms on the Kubernetes container, that in case there is more requests, just simply send an email or alarm the system admin so they can take care of it. because you can't be all the time sitting on the server seeing how many requests are there. Then it also helps you to monitor it. So you will be able to see the whole dashboard, which you'll be seeing how many requests are there, right? What's the traffic, how many instances are running right now. So CloudWatch is really essential tool. People normally, when they work on these kind of systems, they neglect monitoring, right? They think it's the secondary task we can do, but it's a primary thing. You have to always monitor your services, look for any errors, fix it. If you're not monitoring is kind of taking a feedback of an application, right? If you're not taking that feedback very frequently from the user, because user can't, there are millions of users, they can't give you feedback all the time. You can't read those million feedbacks, right? You can't ask a user if there is an error, just fill up this form. You have to make sure your application is smart enough to let you know in case something happened. If there is an error or there is a downtime, anything that needs care to be taken care by your system admins. Make sense? Okay, so let's get to last part. Now we're going to design the Airbnb application. So this is a very high level look of how it will look like. You will have host, you will have travelers. So Airbnb will have two services, demand service and supply service. So we decoupled the services because which will have more traffic? What do you think?
Depending on the time of year, demand more than likely.
So
Demand
obviously a
services.
company is, if it's only it companies in profit when they have more demand, right?
Mhm.
So
Yeah.
demand service will be having more traffic and supply service will have less traffic. So that's how we decoupled it into two big, you can say on a very high level, right? So whenever a new host, there's a new accommodation added by a host, it will go through supply service. Then you will queue that in your SQS queue to put it in the demand service, because these two things are different. They hosted on different servers. They don't link to each other. So this is the architecture we're going to go through. So this part is still here. I can't select, I can. Okay. Till here, it's your demand service. And till here, it's your supply service. So let's talk about the supply service first. So as a host, when host will add a new accommodation, right? It will go through load balancer and then host service. So host service will be hosted on EC2 instance, right? That's you can say service as APIs, right? So those APIs to add a new accommodation will be hosted on EC2 instance with EKS. EKS is your Kubernetes. So in AWS, they provide Kubernetes in the form of a service that they call EKS. So whenever there's a new more traffic, auto scaling group will automatically spin the copies of your host service. So you'll inject the auto scaling group right here. And then when you add a new accommodation, it will add it into the database, and any images that you add for that accommodation will go to your S3. Okay, well, I didn't mention S3 that we're gonna use S3. So what I forgot to mention in the slides. So what do you mean by S3? What do you think S3 is?
More like storage service?
More like a storage service, okay.
That's like to store non-relational data, like images.
Yep, that's right. So your S3 basically is used to store images, documents, text files, any physical file that you're going to use in your database. It's being stored in the S3. So right now in Feed app, how are we storing the images?
Locally.
Base 64.
In the database, right? What are the disadvantages of it, or what are the advantages of it?
Advantages, they probably can get access to the information much more quickly.
Yeah, that's the advantage. Yeah.
Disadvantage is that it takes up more resources to host your data.
What kind of resources?
Memory itself.
Okay, one. Then
it also takes up reading time as well.
that's right. So these are two major things. So when you're storing the data images in the database, two things. First thing is it will take a lot of memory, right? Images are like in megabytes. It depends on what user uploads, maybe in 500 KB, 1 MB, 2 MB, 3 MB, right? So you can't compress it every time. You can compress it to a level, but you can't compress it to such a level where you get the pixels as distorted, right? So if you store in the database, you will that service, or you can say that database will consume more memory, right? It will take more space. Second is whenever you're going to fetch those images, it will take more, it will put more load on the traffic. So you will have, let's say if a packet was supposed to be 10 KB for a request, it will turn out to be, you have to need to add in 10 KB plus the image size, right? So that will kind of block the traffic. So for that, we don't normally store. For learning purpose, we need to learn that why we store it. That's why we have it in feed app. But normally, the next level is to take the images out and store it in the S3 buckets. So Amazon S3 buckets are used to store the physical files. So anything that have that can't be ideally stored in the form of text, right, in your database, we store it on S3. So whenever you're going to add a new accommodation, it will go into your database, any media file will go into your S3 bucket. And how we can relate these two is we can simply store the URL or the path where that image is stored on the S3. S3 is like you can think of S3 as a folder in your laptop, right, where you're going to store things. So you will store the path of that image in your RDS database, right? Whenever you need to fetch the image now, you simply take that path from your database and get it from S3. And that will be very less time based on how you're going to do it with RDS. And your database will still, it will save a lot of memory if you divide these two things. You divide media to store it in S3, and all the data that can be stored in textual form goes into your RDS or your database. So after that, when you're going to add a new service, right now that service, a new accommodation, right now that accommodation is on your host service level. It's stored in the database of host service. A client or a user can't see that accommodation. So what you need to do is you need to add that service to your supply side as well. So what you'll do is you'll implement SQSQ. So if 10 new accommodations are being added at the same time, you can't really block this whole level, this part, just to do a synchronous processing on all the 10 services or 10 accommodations. You have to make sure that you give an instant response to the user host that your service has been or your accommodation has been added, and later you just put it into the SQSQ. So when those 10 accommodations are added, they go in the SQSQ, and SQSQ will one by one keep giving the accommodation to update service. So what update service will do is it will keep getting a new accommodation each time from your SQSQ and keep adding it to your supply side. How it will do is it will be using Amazon Elasticsearch here. So Amazon Elasticsearch will act as your database for the service, right? So it will hold all the accommodations. Those were added by the host, because searching in a database will take more time than searching in a object that has key value pairs, and Elasticsearch is made up of key value pairs. So then now let's talk about the client side. So whenever a new user comes in, you'll use Route 53, right, to redirect the user to link the server with the domain name. Then you will have load balancer and CDN here. So if you're opening Airbnb stat, let's try. I'll show you what is being cached. So if you talk about this website, what do you think is cached from this website, and what is fetched from your database?
The search results are cached. And the images are fetched.
So, or let me frame this better. What do you think is coming from CDN?
The entire everything that is not an image.
So this logo, does that change frequently or based
Well,
on user input?
no.
This comes from CDN. These
Yeah.
logos are coming from CDNs.
And the
right?
icon.
This icon is coming from CDN. This is coming from CDN. Then you can say any static page, let's say on support and resources, you open up careers page. This image is coming from your CDN because that was already loaded in the CDN. This whole content is coming from your CDN. So CDN kind of cache most of your website data that is not based on your user changes, right? It's smart enough to do it. How it does it, whatever is there in your assets folder or images folder, right? It caches that data. So when you do a request on your server to open up this page, homepage, right? What your application will do is this Route 53 will connect to CDN and get the data that is cached, the static data. Then it will go to the load balancer, right? So let's say you're going to view the services. So to view the services, this is a big Kubernetes container, right? Hosted on EC2 server. And here you have small services for each task. So let's say if you're going to view all the, if in case of this page, we're viewing all the accommodations, right? So it will go to your view service, right? And view service will get the data from Elasticsearch. So they do options here, either Elasticsearch, either view service, get the data from Elasticsearch and store it in a separate database right in the service, right? Or it at the same time goes to Elasticsearch. So it depends how you do it. This is a very high level thing. Inside here, you will have caching. So this will have Redis cache, right? This will have Redis cache. So these two will have caching. Payment service will have another third-party service that will be linked to do the payments. And these will be linked with each other using a bus system, or you can say pub and sub system that will help you to communicate, because these can't communicate. So if payment service have a database and view service have a database, they can't communicate. View service cannot communicate with the database of payment service directly. You have to make the internal private routes between these two services, in which only these two services can communicate with each other. Those routes are not public to the user. And then you have auto scaling group. It will scale each of the service based on the number of requests or traffic is there. Make sense?
Yes. You could explain the concept of background processes.
So background processes are mostly done using implementing the services like SQS, SNS queues. Then you can implement publisher and subscriber model. So how it happens is, let's do it with a basic example here. So same example I'm going to take. So let's say if you're going to send an email, right? In user service right now, if we talk about how it's doing in our application, in our feed app, is login service is calling email service, right? And you're waiting there for the response probably from the third party server. So when you will, in case of microservices, when you will set up this instance, what you will do is you will just when there will be a new request to send an email, you will queue it, right? And this queue will have the requests. So when you queue it, you won't even wait for the response whether that request has been queued or not. You will just do an asynchronous request to queue it, right? And then email service will be, this is publishing, email service is subscribing. So email service will be subscribing to your queue. Whenever there is a new record in the queue or new request in the queue, your subscriber will know that yes, there is a new request, you need to process it. So it will process it one by one. But a user service, it did a task, it just simply queued that request to send an email, And then email service will keep taking one by one the request to send an email from your SQL queue and sending those emails. So this is asynchronous processing, and microservice is based on asynchronous processing. Make sense?
Yeah, in a sense.
Okay.
Basically, reading from whatever the user service. The user service is basically creating a task job for the email service to do.
That's right. So now, for example, let's say you are, let's say in the user service, now you update the profile picture of the user, right? So in which services you think you need to update it?
Read service.
Right? And timeline service.
Timeline service.
So SQS basically is 101. So only there can be one subscriber and one publisher. So what happens is you have another one called SNS. So what SNS does is whenever a new profile picture is updated in the user service, you will log the request in the SNS queue. So what SNS queue will do is it can broadcast to one or more services. So now we need to change in the feed service, and also you need to change it in the timeline service. So SNS queue will broadcast those requests to two services. So there are some disadvantages of using SQS. There are some advantages of using SQS. Same thing for SNS. You have to make sure you choose one of it smartly based on the requirements of the project. And SQS will be faster than SNS. Okay, that covers our workshop for today. If you guys have any questions, feel free to ask.
Just a quick one, like, could you just explain a bit on the auto scaling again?
So auto scaling, what basically will do is initially, let's say you hosted service, there is one instance each for each service. Now, let's say you're getting more traffic on such service, right? So what auto scaling group will do is it is monitoring the number of requests you're getting on each service. If it thinks that your search service is getting overloaded with the request, and what it will do is it will automatically spin more instances, create copies of these, so that more users can be handled. So you will get like replicas of search service like this. So if your master service, then nothing acts as a master. It will become like this, right? So this is how auto scaling will scale it.
The auto scaling doesn't mind even if it's a monolithic application or a microservice application, it still just does the same thing.
Yeah, it still does the same thing. So if your request comes in, Kubernetes will check if this is handling right now some requests and can't handle more. It will ask the second replica to handle the request, then third, fourth, fifth, sixth. So these are, let's, for example, you are hosting your database, or sorry, your APIs on the GitHub. So GitHub, whenever you spin more services, it will always get the new code, the same code from your database, or sorry, from your GitHub, and spin it.
All right, thank you.
Okay, any other questions?
I don't see any hands in the participants window here, so we're coming up on 4 p.m. anyway. But everybody, give some thanks to Yuvraj. That was really thorough, and this is stuff that you're going to be thinking about. There are a lot of teams at TD who are going to be thinking about this kind of thing. So, great work, Yuvraj. Thank you.
Okay, no problem, Charlie. Then I let you guys go. If you have any questions, concerns, feel free to Slack me anytime. Okay, have a great rest of your day, guys.